Hello, this is our science fair project. My team and I will tell you everything you need to know about how Eratosthenes measured the Earth. In 2000, humans started sending satellites into space to get accurate ground measurements.
The satellite wasn't the first method to measure the Earth.
Lalo, tell us about who was Eratosthenes.
Eratosthenes was a Greek philosopher, astronomer, geographer, historian, mathematician, and writer, recognized for being the first to calculate the circumference of the Earth. Alright, Maggie, tell us about Eratosthenes' method.
Although it sounds quite simple, his method does have its difficulty. It consisted on planting a stick onto the ground and wait until the moon created a shadow. Next up, this method will be explained in greater depth.
But first, who was Eratosthenes? Eratosthenes was born in 276 before Christ in the ancient city of Cyrene. He earned his fame because of his knowledge in various areas. He knew about lots of things, like math, geography, poetry, and astronomy. A very wise one may say. Archimedes gave him the nickname Pentatone, but he was not the only one to give him a nickname. His critics called him Beta.
He cultivated poetry and philosophy, and even taught the children of Ptolemy, which means he was not only smart, but also kind. He is best known for calculating the circumference of the Earth using previous knowledge. He really was brilliant. He also calculated the obliquity of the ecliptica, and is known as the father of geography. His achievements were great, but all good things must come to an end. He passed away in 194.
Air measurement relied on the approximated distance, as well as the approximation method, and did not require detailed observation. He predicted the Earth was 39,600 kilometers as compared to our measurement today, which is exactly 40,009. This amazingly close. Eratosthenes has estimated the diameter of a planet to be 250,000 states.
He came to this conclusion because Eratosthenes understood that the range between Alexandria and Cyone was 5,000 paces. He also realized there were 360 degrees in a circle. He simply divided 360 by 7.2 and considered the answer to be 50. If there were 50 fragments around the Earth, equals to the distance between Alexandria and Cyone, its diameter was 250,000 kilometers.
Other discoveries of Eratosthenes. He was the first to prove his claims, which is why he is considered as the first mathematician in history. Also, he identified that there are five geometric theorems. He developed a geometric method, which will allow him to calculate distance from the Earth to the Moon and beyond the Earth to the Sun. And even his results were not as accurate as in reality they are. The method is perfectly correct if we analyze it from the point of view of the history of science.
He was the first to explain why the Nile River flows each year, seasonal rains falling near the location of the river, triggering an annual flooding in Egypt. He is actually recognized as the father of geography because he created the world's first map with Mediterranean lines and parallel lines. These were identical to current latitude and longitude lines.
The importance of this. So although it may have been in ancient times all these discoveries, we can realize that without the technology we have today, we are able to achieve this calculation almost exactly using nothing more than our abilities, mathematics, and knowledge. So it was very important what he achieved because he is still encouraged.
So, in conclusion, it was very important because he made this discovery, and thanks to it, we can see that mathematics are actually very important for making greater advancements. It is very important to have knowledge of mathematics and have an open mind, always in the pursuit of solution, with being independent of a calculator or computer, because, like Eratosthenes, we can basically solve any problem by using our logical and mathematical knowledge, and this makes making life easier to understand.
So now we are gonna make an experiment to explain how did Eratosthenes measure the Earth. So the materials for these experiments are a dustpan, a compass, paper, tape, a notebook, a rule, and a pencil. Also a chronometer and lighting.
And now, time to do the experiment. Our first step will be to collocate the dustpan on the paper in a way that the shadow of the dustpan matches with the paper. Now we are going to do a mark where the shadow ends. We will make a mark where the shadow ends. Now we will set the timer for 5 minutes. Now we will have to write down some stuff. First of all, we need to write down the length of the shadow. Also, we need to write down the times. After the 5 minutes are done, we will have to make another mark where the shadow ends. As we can observe in the results, the shadow length changes as the sun moves on. But now you're probably asking yourself, how does this relate to the topic? Well,
In this experiment, we can do a part of the measures that Eratosthenes did. Obviously, he did in a much bigger scale with Alexandria. We can observe that even though the process of Eratosthenes wasn't complicated, it was still very creative, intelligent, and impressive.
Have you ever questioned, do you also need mathematics to make a video game? Well, want to know the answer? Enjoy, and this video will seek to answer why do I need mathematics in a video game, which all minutes indicate itself is a very close relationship. Also, we'll show some of the application of mathematics for the elaboration and development of the video game Roblox. In order to start, we have to know what is mathematics. Mathematics is a science that doesn't only study the nature of numbers. They were designed to be applied, and their value becomes more apparent. Today, they are used around the world. Surely, many people throughout their preparation have asked how they will use those classes, since they will largest musicians or journalists. Also, at first, it does not leave an obvious use. Mathematics helps to develop abstract thinking and the optimization of different problems. You have probably heard of video games. A video game is an interactive digital entertainment people play with a diapositive. Also, many people are not aware it was mathematics at all times. There are extremely complex algorithms and formulas. There are a million different kinds of video games, and basically mathematical application involve their entire process. Science people don't know knowledge of this, just say everything is a video game without knowing the part that make it up. It is confusing, even for those who specialize in this topic or this you will call gamer. However, you can find how to use recent academic works to approach new design methods and know more about the video games world. Let's see a little how. Numbers are the foundation of mathematics. There are many different types of them. With a mixture of numbers and letters, we can develop the different equations and algorithms that detail the creation, action, and movements of the video game and characters. In the video games, we can use state variables. Much of the data in the video games is simple operation like addition and subtraction. This data shown in the HUDs change according
to the various actions in the game or in the final result. For example, if the fire, then the bullet container decreases because for every shot the number of bullets is equal to the number of bullets minus 1. Those are other cases. A coordinate represents a single point using number lines as rules to measure the distance from the bottom left corner to the screen. The first line is called X, which runs from left to right. Second is called which runs up and down. When we write down these coordinates, we always put the X before the Y, like this, meaning that the X coordinate is 200 and the Y coordinate is 50. One of the basic areas of video games and animation is designing 3D images on a computer using mathematical formulas. The place where the objects are located and the location where the character is in reference to those objects. Even in basic 2D games, the math is what tells the game if the character jumped off a solid platform or fell into a hole. Another area is the design of world physics. Regardless of whether the game world is simple or complicated, there are always physics that must be applied. If a player presses the jump button, the height the character will reach must be determined. If a soccer ball is kicked, it cannot follow a straight path, so the programmer must apply the necessary algorithms to decide the direct speed of gravity, etc. Geometry is about shapes and their properties. In video games, it is closely related to the design of the world. The two most common themes are plane geometry, that deals with the flat shapes that can be drawn on a piece of paper, solid geometry, that deals with the objects, and three-dimensional space, that is the space in which we live. In many games, everything is formed from the mixture and combination of three-dimensional figures, polyhedra and not polyhedra.
This also involves some other topics, as volume, angles, trigonometry, etc. With all this information, you are able to create whatever you want. This was a brief explanation about how maths can be found in video games, but now we are going to analyze them by playing in Roblox. Do you know Roblox? It's a video game created to play in multiplayer where you can design an avatar, create and play your creations. Well, this game is full of mathematics. In Roblox, with a mix of numbers and letters, create emotes that are small codes that allow the character to perform an action. To use these commands, write in the chat, /e, leave a space and put the name of the mode. For example, it dance. We can find state variables in the charts that show the number of likes, score, number of coins, or money called Robux.
Those are great examples that use some of the basic operations like sum and subtraction. As you can see, every player has these variables at the right top of their screen. Roblox use coordinate to represent a character's position on a screen, and depending on how a character moves, their position might change along the x-axis, the y-axis, or both. Players often use these to identify where they are located, where something is or someone. Roblox involves a lot of world design because players twist the world. The images that the players see from the character passing from the stage to the enemies and obstacles are made up of the mix of polygons and 3D figures like these buildings. This boy with the mixture of cubes and cuboids of different sizes is building a whole tower, while the avatar is made of a sphere and cuboids. According to your taste, you can create anything. In Roblox, we can find some physics for the different actions that the players may be doing. For example, if they fall down, the programmer must apply the necessary algorithms to decide the drag speed or gravity like in this video. In Roblox, geometry forms part of basically everything, since all the environment and characters are formed the mixtures and combination of three-dimensional figures, polyedra and not polyedra. Polyedra involves all the figures that must have flat faces like prisms and pyramids, while the non-polyedra are the ones that any surface is not flat like spheres and cones. Can be also changed by volume, thickness, height, etc. as you wish.
Now it's your turn. Feel free to experiment new forms of designing video games. You have seen that many techniques using game programming have a basis in the math you learn at school. You can use this knowledge to extrapolate other ways of doing video games. Never forget, in games, it is the end result that counts, not the accuracy of the underlying model. Math is just another tool to help you get the result you want. This was a brief explanation, but with this in mind, feel free to experiment with new and different ways of making objects move because why should be restricted by the mundane context of reality? Your imagination can be so much more fun and don't have limits. Thanks for watching this video. I hope you like it.
Hi, we want to express in this video what the project left us and what it will still left us. For example, what happened to me was objective, and for me this means how to be able the chemistry and the mathematics with the Fibonacci succession, and thus be able to help environment by teaching the importance of a single person planting a tree and then more people join. We will continue with my colleges.
Hello, I'm Santiago, and I'm going to explain some words that we use in text. The first one is sequence. The sequence is a particular order in which related events, movements, or things follow each other. The next one is algorithm, a process or set of rules to be followed in calculation or the problem solving. Operations, especially by a computer. Integers, a whole number, a number that is not a fraction. It can be all the numbers that we can count, like 1, 2, 3, 4, 5, 6, 7, 8, etc. Sanskrit is an ancient Indo-European language of India.
Okay, to know about the origin of Fibonacci succession, we need to go back to the 3rd century before Christ. In this century, the scientific Indians start with this succession. It wasn't perfect, but they started to use it. After that, a few centuries later, to be more specific, in the year 1202, Leonardo de Pisa, better as known as Fibonacci, perfectionate this succession. Well, it take his name, and how he left this succession is how we know it nowadays. Thank you.
What is the Fibonacci sequence? Well, the Fibonacci sequence is a mathematical algorithm that will help us predict the growth of a natural event or events we usually have in humanity. So, for example, we have a plant and we want to know how many plants or how many branches this plant will have in a certain period of time. So we can calculate that with the Fibonacci sequence. It works the same for animals, and for example, for animals we have bunnies, we have cats, we can have dogs, or even bees. It works for everything. So the Fibonacci sequence goes like this: 0, 1, 1, 2, 3, 5, 8, 13, and so on.
Hello, my name is Jesus Hernandez, and as everything in the life, the Fibonacci sequence got some curious and incredible properties, like the next ones. Number 1, the Fibonacci sequence. is the most prominent example of recursive sequences. Number two, the general Fibonacci sequence is seen as coefficients of the corresponding generation function. And last but not least, number three, one of the interesting properties of the Fibonacci sequences concern the realm of discrete mathematics is that is a solution to a linear homogeneous recurrence relation with a constant coefficients. So those were some of the most important properties of the Fibonacci sequences. So now
So I'm going to explain the correlation between the Fibonacci sequence and the Pascal triangles. This is a very easy correlation. It's the thing is that no sum the numbers well the result of the sums of the numbers of the Pascal triangle will give us the terms of the Fibonacci sequence. Uh, as we can see here, like this: 1 plus 1, 1 plus 2, 1 plus 0 plus 1, and these numbers will give us the Fibonacci sequence terms, as we can see here. In the case that they don't have like number 2 sum, it will pass like only the number, and this will give us the terms of the Fibonacci sequence, and that's the relation that they have.
Mathematics, two quantities are in the golden ratio if their ratio is the same as the ratio of their sum to the larger of the two quantities. Mathematicians since Euclid had studied the properties of the golden ratio, including its appearance in the dimensions of the regular pentagon and the golden rectangle, which may be cut into a square and a rectangle with the same aspect ratio. The golden ratio has also been used to analyze natural objects as well as man-made systems such as financial markets.
How to apply it in nature. The Fibonacci sequence is an essential part of nature as a clear example that they put when they present us with a topic that of bunnies. Everything follows this sequence, the form of things and the way they happen. It is a pattern that nature follows from three or two animals, and it is important for us to understand how this works. A mathematical sequence is a definite application over the natural numbers. This, in Spanish, means that is a series of numbers that is generated by applying certain rules. In fact, it is very easy to imagine a sequence of numbers, and there are infinite numbers of them. However, some are more famous than others. In general, it is intended that the way that give rise to the sequence are as simple and clear as possible.
Hi, my name is Carlos Corona, and I'm going to explain how we want to use the Fibonacci succession to help deforestation in the world. So here I have a simulator in which we can see how every time I click this button, the Fibonacci succession happens. So I hit it twice, and there's 8 seeds. Well, this simulator is to represent how the sunflower seeds are born, but we're gonna represent the seeds as the trees. So what we want to explain with this is how quickly we could reproduce trees to help deforestation. Instead of solving this problem in a matter of decades, we could do it in just a few years, which is a massive outcome. So yeah, that's what we're trying to explain. And as you can see, each time I press this button, more seeds and more seeds come out, and that's our idea of how we could help deforestation. So yeah, thank you.
is an intrinsic part of the nature of man. From a very young age, we play with all kinds of things, cards, stones, marbles. We use games to learn and develop our knowledge about the world around us. Magic and math have long been traveling companions with us, but magicians and mathematicians are motivated by the sense of surprise that represents the essential mystery of the world. The magicians display such astonishing facts, while mathematicians try to explain them. The science of illusion versus the illusion of the science.
The main idea of the team is that we naturally believe that math is the method for having a result in the correct way. But now we can appreciate more about the different ways to get a result and the different branches it covers. You may think that mathematics are boring. That's why our objective is to imply that maths are not only about numbers and operations, etc. Then you may realize that we can play with maths, like the following games that we are going to explore.
Why use math and magic for teaching? Math and magic may seem a strange combination, but most of the magic tricks that we have nowadays use math bases. Also, most of the famous magicians, such as Darren Brown and David Blaine, use math tricks to their performance. A fact is that nowadays, math is the secret behind the technology we use. A perfect example that demonstrates the relationship between both is the one we could think of a number trick. Magic is so attractive to human beings that it's impossible to think of one person that do not like to see a good trick.
A magician is a person who shows a surprising, inexplicable fact before us, and a mathematician is that person who tries to explain mysterious fact that on many occasions comes in magical. That's why we can associate the two professions in something in our daily life. According to Christian Bailey, the subject of mathematics is most often associated with logic, rules, and reasons, something thought it's best served with a side of magic. We know that one of the less appealing subjects is mathematics because of its abstract nature and complexity. But it is also one that gives some of the most necessary tools that we will use in the future, and there's need to make math interesting. That's why over the time they have been discovered and implemented new learning method. Magic is closely related to math in the science behind it can be used as a resource to help to learn mathematical skills and increase interest in math.
If we ask about the name of a mathematician, the majority will name Pythagoras. At the time, Pythagoras thought science was related to mysticism, and it was because the vast majority of the population didn't know why things happened. Therefore, they thought it was magic. The relationship between science and magic has continued to manifest itself throughout the centuries in many different ways. The first printed book that refers to mathematical magic was De Subtilate Venum, dates from the 16th century, and its author is Dr. Gerolamo Cardano. Later works mixed mathematics, physics, chemistry, and magic in one titled Recreation mathématique et physique, written by Jacques Massorano. Also, the book Mathematics, Magic, and Mystery, worked by Martin Gardner, was the first book that totally focused on mathematical magic.
Processing mathematical formula is a cognitive task that most of us do every day. A recent analysis of the processing of different structural hierarchies in mathematical formulas found that the ventral amount of the left anterior inferior frontal gyrus, in addition to the bilateral temporal medial and inferior parietal zones, show an increase in activation in response to complicated hierarchical constructions compared to flat constructions. Here, we focus on the neural basis of processing the semantic content of mathematical formulas that are their truth value.
With all this information, we can realize that by combining game and illusion with the mathematical content, it will be possible to capture attention and promote effective learning. Of course, there are some tricks that don't involve mathematical calculations or cannot be decomposed and studied through them. There are magic tricks that often hide the immediate secret using cards, coins, or hats. The simplest of them is to use numbers, like the ones we are going to see for.
The first game is about giving support to the children who are going through a stage of basic learning. With this activity, they don't get bored while the child is acquiring knowledge and they are practicing.
For example, an elementary school child is learning to add, subtract, multiply, divide, the basic operations. As we know, at that age, children have a different mentality from an adult. For them, it's very difficult to learn mathematics or just have theory in their classes. So it's easier for them throughout a game. They can distract them and help them to learn. In this game, we use arithmetic mental and we find character by the classification.
Now I'm going to tell the general idea of our workshop. The general idea is to share a magic trick through math and change people's ideas about what they think about math. Through new learnings like being able to have fun using math since we've never really done it. The purpose is to show people that maths are not that boring as they look like. And we can learn a lot about them just by doing some game exercise. A lot of people hate math because they think they are stressful and boring. But when they start to see them in a different way, math becomes better and fun. People will be surprised how many ways we can play with numbers. This kind of game with operations helps human brains speed it up and keep it active while we remember all the knowledge. It is something fun that you could use it with your friends and waste time.
We are going to play a game. So you must think of a character and I'm going to try to guess it, okay? So think your character. You got it? Yes. Okay. So then I'm gonna say some questions and if you answer correctly, you have a chance to give me your characteristic, okay? Yes. So let's start with the first question. The first question is subtract 70 of 518.
Okay. 448.
Yes, correct. Okay, the first question of your characteristics is your character female?
Yes.
Okay, so second operation 1000 plus 1 minus 3.
Okay. 998.
Okay, yeah, great. The next question is your character a superhero? The next question is 3 plus 3 plus 2 plus 4.
12.
Yeah, great. Okay. The question, does your character really exist?
No.
Okay. The next operation is 5 multiplied for 7 plus 15 minus 3.
Okay. 47.
Okay, yeah. The question is, does your character have magical powers?
No.
No. Okay. The next operation is 270 divided by 3 plus 2.
306.
Okay, yeah, 62. The next question, is your character an animal?
No.
No? Okay. The next. 3 plus 20 minus 4.
19.
Yeah. Is your character blonde?
Yes.
Okay. The next question is 150 plus 3
minus
12.
It's 142.
42, yeah. The question is your character a Disney princess?
Yes.
Yeah, okay. 8 by 7 minus 11.
46.
Yeah, great. Okay. Has your character lost a shoe?
Yes.
Okay. The next question is subtract 13 from 29.
It's 16.
Yeah. Okay. Does your character wear a blue dress?
Yes.
Okay. It's said that your character is Cinderella. Is it right?
Yes!
Okay, and we find the character that it was Cinderella. Yeah.
Music is an art concerned with combining multiple or instrumental sounds to make an emotional expression. Math is defined as a formal science and a precise science that studies the attributes and the relationships that are established between abstract entities based on logical principles.
It is not credible to say that math is everywhere we go, and also in music. And you might be wondering how. There are certainly undeniable similarities, such as the fact that both are so abstract that they seem to belong to another world, and also they still having great power in this.
Music affects the listener, and mathematics has multiple practical applications. One part of mathematics studies numbers, their patterns and forms, and these elements are inherent to science, composition, and the performance of music.
In a specific way, we're going to explain how the music and math get along with a diatonic scale. The objective, in a general way, is to explain the relationship between music and math and how they get along.
A musical scale, as we know, is attributed to Pythagoras, a Greek philosopher and mathematician who lived around 550 before Christ. Legend has it that Pythagoras listened to the hammer of a blacksmith hitting the anvil and found that the tones produced by the hammer were related to the weight of the hammer, and to his great surprise, the weights came together in simple integer rings. After further research, it didn't take long to him to realize that the consonant sound, tones that sound pleasant to the ear when played together are in the simple relation to each other. There are two assumptions when trying to create the Pythagorean scale. Or a scale will consist of a series of notes, or a scale should contain notes that produce a pleasant sound when played together, which means that the frequencies of the notes should be ensemble.
Okay, each of these dots are frequencies. These frequencies are the fifth of this one, and this of this one, and this of this one, in order to create a new note. When we have a scale of notes or frequencies that are symmetrical and will form a regular star, we will have created a scale that is nice to the human ear. Okay, as you can see, this is a regular star, and this scale sounds like this. And in particular, this scale are the pentatonic scale by Pythagoras.
Okay, so I'm going to tell you what the harmonics are. The harmonics are one of the parameters that generate the characteristic timbre of a sound source. For example, a guitar, a fiddle, or our own voice. To make it easier to understand, I'll use my guitar and its strings as an example. When we make a string vibrate, it generates a musical note, which this musical note is conformed by various harmonics. The most important one is the fundamental. To explain how the fundamental works, try to imagine a string that vibrates and it has a crest in the middle and it vibrates like up and down, up and down, up and down. The second harmonic is basically the same as the first one, but it has two crests. And it vibrates like a wave. And the third one has three crests, fourth one has four, and so on and so on. Knowing this, we can say that when we play a string, we're playing all of its harmonics at once, but with different volume.
The only material you will need to do this experiment is a piece of string. The first thing you will have to do is to tense this string. You can do this by tying it to something or just asking someone else to hold it for you. Then you will have to play it twice, one with the full length of the string and another with just a half. You will see that both sound pretty similar. Finally, you are going to play it one last time, but this time with 2/3 of the string. You will notice that it sounds different than before.
My name is Emma, and this is my partner Sosa.
Hello.
And we are from Team 1, and we're going to explain mathematics and music. Our experiment is based on strings.
So, in this experiment is based on the string theory that the ancient Greek discovered. This theory said that if you cut the string of a guitar into a half, you are going to get the same note that the string has, but with a higher or lower intensity. The funny fact here is that if you cut the string into 2/3, you are going to get a new note. Yes, a new note. So this experiment is mainly to confuse the tune of guitar tuna. We are going to get confused on that. Human is better than robots. So please, Emma, play the fifth string. As we can see, the fifth string is represented by the letter A. So now, Emma, please play fifth and in the second plate. We are getting the same note, but in this case, we are getting in a lower intensity. Now, Emma, please play the fourth string. It is represented by the letter T. But here is the funny fact. Do you think guitar tuna is getting the same note when we play it? So please, Emma, fourth and fifth plate. Another time, please. Fourth string and fifth plate.
Yes.
There it is. We are gaining a new note that it is G. It is the third string. You can see. And we get confused. The guitar tuna J. So this is all for us and for you. Okay. So see you.
Symmetry, such as a concept, it is called the equal size, positions, and proportions of a whole. We can find symmetry in many areas, just like mathematics, geography, geometry, science, graphical designs, and many others. Symmetry is very important everywhere, because if it is not a balance in any object, just like a human being or a non-human being, there can be malformations and affect itself.
The general objective of symmetry is that this is a certain figure with all its sides equal to the others that correspond to it. From origami is to make a paper figure in third dimension without cutting absolutely nothing of the paper. Together, symmetry and origami make a perfect paper figure.
Our specific objective is to prepare an excellent project with all the information that it can be understood by everyone and can be useful for their activities and their life. In conclusion, we want that everybody understand the importance of this. We will show you everything you should know about how to make a perfect figure.
About symmetry. Symmetry is the exact correspondence in size, shape, and position of the parts of the whole. An example of symmetry is the Betrayed Man by Leonardo da Vinci. Greeks were the first to study it in essence, along with arithmetic and geometry, and passed the word on to use. For example, we relate the relationship between musical harmony and mathematics.
Symmetry is very important since we can find it in our environment and it is studied in many cases. We can find symmetry in the human face and in many living things. Symmetrical objects also appear in situations of our daily lives, like in constructions, logos, flags, tiles, and in decorations. Symmetry is very constant in everyday life, like for example our phones. Some examples of different kind of symmetry are the axial, rational, central, translation, magnification, and bilateral symmetry.
Hi, my name is Juan Carlos Flores Juarez, and I'm going to explain about the origami. Well, where did it come from? The origami come from China in the first century before Christ. And in what consists? Well, it consists in to make figures with paper. And also, an important rule of the origami is that you cannot use scissors or something like that. You can only make precise folds. And well, talking about folds, here is a lot of types of the origami. Here I'm going to show it. The classic origami. It is the best known in the world. It is a typical way to make origami figures with a single paper generally, and with very precise folds. Here we have as an example the classic origami crane. Modular origami or action origami. This is one of the most colorful and incredible origami that can be made. It consists of making several folds, also adding another sheet in order to form a figure where we can move it as its name indicates.
So, well, based on this information, we can see that origami and symmetry has a relation with size, shape, and position because there are many types. Around the world, we can find different objects with a perfect or without perfect symmetry. The question here is why is it important? That's so important because we can analyze, and that not means that just analyze and that's all. If not, it is more than that because that's so useful for our daily life. Then here's a part where architecture and mathematics joins because you have to know it to do it. Then that you know it, you can do everything that you want. You can do new projects, you can do change the world if you want, you can do everything.
The purpose of the workshop is to follow a list of steps to make a figure without cutting anything. Also, this helps you to improve your level of understanding, comprehend, and follow instructions, and also to know that everything has a size, length, symmetry, and an order.
Now we are going to do the workshop. The purpose of the workshop is to follow a list of steps to make a figure without cutting anything. Also, this helps you to improve your level of understanding, comprehension, and following instructions. And also to know that everything has a size, length, symmetry, and an order. For the workshop, you're going to need two rectangles of 20 centimeters long times 10 centimeters wide each one. First step, take the rectangles and fold them in a half of the widest part. That one is the part of 20 centimeters. Second step, fold the 10 centimeter part again in a half. Third step, take the rectangle and unfold the last part and make a small triangle from the extreme right through the previously marked line from bottom to top. Fourth step, do exactly the same with the other rectangle. We take the right end from top to bottom. Fifth step, take the left end of the figure and take it from top to bottom. Sixth step, take the left end of the figure and carry it from the bottom up. Seventh step, turn them over and you will see a square in the figure. Eighth step, From the figure, we take the square below the lower right corner to the upper left corner to obtain the shape of a triangle. Ninth step, flip it over and do exactly the same with the other square. 10th step, with the other figure in the square below the lower left end, we take it to the upper right end and we do the same on the other side. 11th step, turn the figure and put it this way. 12th step, place the upper right part of the first figure in the left triangle of the other figure. 13th step, place the bottom left of one figure in the right triangle of the other figure to get something like this. Flip the figure. 15th step, place the upper part of the left side of one of your figures in the right triangle of the other figure. 16th step, place the lower part of the right side of one of your figures in the triangle on the left side of the other figure. And there's where you get the final result. Workshop made by Alexia Dominguez Cortez and Greta Davila Castillo.
That was the result of the video. It's a small demonstration to understand better the topic about symmetry and origami. Thank you.
This work is the final product of the investigation of all of us, in which we are explaining the exponential model and its application specifically focused on the reproduction of dogs and cats on the streets in Mexico.
Objective. The objective of this project is to demonstrate the numbers about the reproduction of dogs and cats in the street using as base a mathematical model to understand better the situation. This work wants to show you how a mathematical model can be useful to prevent a social issue that is very important nowadays in our society.
Now we are going to talk about the mathematical background. As we know, the subject that is going to be presented is a graphic representation to reach our objective of conscientization public. In this specific case, the graphic representation is going to be an exponential model based on the data that we recover from different didactic sources. First of all, the models have different uses or a variety of uses, from providing a way to explain different information or complex data into transforming it to hypotheses. There may be more than one model proposed by scientists in order to explain or predict what might happen in different situations or different circumstances. Models describe our beliefs about how the world functions, and in the mathematical modeling, we translate those beliefs into the language of mathematics. Before knowing what is an exponential model, we need to know what is a mathematical model. So, what is a mathematical model? Well, a mathematical model is an abstract model that uses mathematical language to describe the behavior of a system. And the mathematical models are used particularly in natural sciences and engineering disciplines, such as the physics, the biology, and the electrical engineering, but also in the social sciences, such as the economists, the psychology, and the political science. Also the physics, the engineers, the computer scientists, and the economists use mathematical models most extensively.
This kind of mathematical model can be applied in different circumstances or subjects. For example, in anthropology, modeling can help to classify and reconstructing schools. In archaeology, in the reconstruction of objects from preserved fragments and classifying ancient artifacts. Also, in architecture can help to build a type of virtual reality. In arts, on computer animations, and many other things. Exponential models are applied in various situations, different topics, and different investigations. They serve as support tools for research and growth reports. Now that we know what is a mathematical model, let's go to know what is an exponential model. The exponential model is a mathematical model specifically used to graph the growth of population, the epidemic spread of a threat among a population, or simply measure the growth of the things in a certain amount of time, based on exponential growth.
The person who invented the exponential model was Thomas Robert Malthus. Thomas was the one who developed a theory on the exponential growth of the population, and he made a work called An Essay of the Principle of Population in 1798. Thomas Robert Malthus was born in the year of 1766 in Dorking, Surrey. In 1793, he became a member of Jesus Court. In 1824, he became part of the Royal Literature Society. In 1833, he was appointed to the French Academy of Moral and Political Science and to the Royal Academy of Berlin. In addition, the inspiration has been felt in different models of growth and depletion for resources. Among them, the Club of Rome report entitled "The Limits to the World." The equation for the exponential model is y equals c by 1 plus r by t, where c is the initial quantity and t is the time passed.
Well, in August 2016, the Mexican Congress researched for help to the state's government to carry out campaigns for canning sterilization and adaptation of dogs on the streets. The main reason that for the abandonment of dogs are the behavior of the animals, which for many people are undesirable, and that regarding to pet people feel disappointed when the pet is bold is not what is expected. This goes by the incompletion of how to have a dog or a cat. The life of a stray dog is usually drained by malnutrition, disease, and especially abuse. All these things thanks to the fact that they don't have the appropriate shelter or they don't have the vaccines to avoid common disease of their species. In addition, the stray dogs also have a lot of problems with the traffic, like run over, traffic, and etc.
Now, with the information that we gathered from the last part, we're gonna take that information and explain the main topic, and then we will demonstrate the data in an exponential model. So let's start with the beginning. Stray dogs. Stray dogs are a pretty bad part of the Mexican culture. Here in Mexico, it's pretty common to walk down the street and see dogs, cats out there in the streets with no one to take care of them. Some of them getting run over by cars. It's a pretty sad situation. The most sad part of it is that some of the stray dogs, are acquired as Christmas or St. Valentine's Day gifts, but time later, months, years, I don't know, the owners can't handle the pet and the dog, and they just live down the street. Well, causing that putting in risk the dog's life and making it like uh, really susceptible to die. So, the Mexican Association of Veterinary Doctors Specialists in Small Species estimates that there are around 28 million of stray dogs, which 70% of them are on the street. The other carry, well, they live in houses. The sad part is that they estimate that this number that grow will grow 20% each year from now on. So yeah.
Street cats. Their technical name are wildcats. They are used the street like a home. It's very strange that we can find in a foundation of cats this type of cats, but we can find this type of cats if the cat need special care. How much street cat exists? Well, doesn't exist a specific amount, but the amount is similar like a dog's. So the amount is similar like a dog. Cats live 20 years, but a street cat doesn't pass like 10 years. The street cats are solitary, but exist little groups of cats that have specific territories. Some foundations have the safety of sterilizing street cats because the amount of street cats is increased and that cause environmental issues. If we avoid attack or even street cats, we avoid all problems in animals or in people.
So in this space, we are going to do the workshop. Now that we know what is an exponential model, and we have all the information that we need, we can put in practice what we learned about the model.
What we are going to do is to try to know how many dogs are going to be after 6 generations of pair of dogs and cats.
To know the quantity in dogs, we have to multiply two that are the parents by the sons that indicate that are four. Then we raise them to the time that we need. That in this time is six, but because they are in the sixth generation.
What we are going to do is to try to know how many dogs are going to be after 6 generations from one pair of dogs. We know that in general, each pair of dogs has 4 dogs from each litter. And in cats, we know that each pair of cats have 6 kittens from each litter. And now we have 2 pairs of dogs. So 4 dogs, or 6 in total, include the parents. And from these 2 pairs, now we have 8 dogs. Now we have 3 pairs of kittens, of cats. So we know that six cats or 8 cats in total, if we include the parents, and we are going to be the number of dogs and cats after 6 generations.
The result in this time is 8,192 dogs. And in the cats, the result is 139,968 cats.
Thank you so much.
Welcome to our presentation of the Mayan numbering system. Our team is conformed by Roy Jalil, Pablo Zurita, Alex Reyes, Felipe de Jesus, and me, Nancy Alvarez. The Mayan culture was one of the most important civilizations of Mesoamerica in the 18th century. The main reasons why this culture stands out from all others is because of the great discoveries and inventions they made. For example, their political and social organization, their temples and pyramids, both painted and built with natural objects, their most advanced writing system, the great variety of languages they used, and their numeral positional system. Mayans created a very unique numbering system that was used as an instrument that helped to measure time. It was a precise tool that helped them to relate the months, days, and years. In this presentation, we will be making two activities in order to explain the values of the Mayan numbers and the relation between their ancient system and our actual one. Keywords: numeral system, Mayans, Mayan system, measure and position. Thanks.
Since ancient times, the human being have the necessity to count. That's why they developed several numbering systems. Some examples of numbering system are the Inca, Mayan, Egyptian, Chinese, and Roman. But today we are going to focus on the Mayan numbering system. Before analyzing the Mayan numbering system, we have to get a context about the Mayan civilization. The Mayan civilization was a group of pre-Columbian towns that governed 18th centuries, from 2000 BC to 1527 AD. The Mayan culture was located on Honduras, Guatemala, Quintana Roo, and Yucatan, and they built important cities like Bonampak, Palenque, Chichen Itza, Tikal, Uxmal. These cities nowadays are archaeological sites where you can see their contributions to the world. The greatest contribution of the Mayan civilization to the world is the astronomy, but also they have contributions on mathematics and architecture. The Mayan civilization contribution on the mathematics is the Mayan numbering system. That is a positional decimal numbering system that is conformed by three symbols: a zero for a circle for the number one, a horizontal oval for the number zero, and a horizontal line for the number five. Now you know more about our ancestors. The Mayan civilization was established in Latin America and Mexico, and it is something to be proud of.
The Mayan numbering system was the first system that included the notion of number zero. In this case, Mayans was the first civilization that included this number. Mayans invented a numbering system which was focused as an instrument for measuring time and astronomy. They didn't use it for mathematical calculations like trading. They do trueques. Mayans developed a positional system that works by levels and figures. Figures, its value is given by the positions, and levels is multiplied by 20. The Mayan system, there are only three symbols: the seed, or the shell, if you call it like that means it's equal to 0. The point, or the circle, it's equal to 1. The rectangle or the line is equal to 5. If we combine these three numbers, we can get any number. This system is a vigesimal system. That means that quantities are grouped from 20 to 20. The rules of Mayan system are that you can't repeat more than 4 times the number 1, or in this case the point. The rectangle, you can't use it in the same line, like in the same level, more than 3 times. So the positions of this system are vertical, and each level is multiplied by 20, and so on.
Hey, I'm going to show you the relationship between the Mayan numeral system and the mathematical functions. First of all, we need to know what is a function. A function is a relationship between two values in the domain and the range, but with another property. The property is that we cannot have one value with 2 in the domain, or the other way around. We cannot have one with the 2 in the range, or one in the range with 2 in the domain. As we can see in this image, the 1 is with the point, the line is with the 5, and the shell is with the 0. So we cannot graph a specific image to show the development when you multiply each level or each sign with the numbers, but we can find the function, which is the one that you can see in the image. And basically, that is the relationship between their system and our system. We cannot make the graph because their system is based on the number 20 and our system is based on the number 10. But let's go with Alex, who will show how to transform from one system to the other. And thank you.
Okay, so we can see that the Mayans were a very smart group of people because they implemented some of the things that we still use nowadays, like the number zero, for example. Also, they invented their own numerical system. They didn't use it for paying or something like that. They use it for counting the time. With this, they invented their own calendar. So, what are some of the main difference of their of the Maya numerical system? Well, first, the Maya numerical system only have three figures: the point that its value is 1, the line that its value is 5, and the shell that its value is
0.
So with all this, we can make a lot of numbers because in the Mayan numerical system, they have 4 levels. The number 1 with its multiplied by 1, the number 2 with its multiplied by
20,
the number 3 that is multiplied by 400, and the number 4 that is multiplied by 8,000. So with all this, we can make a lot of numbers. We can see that the Mayans think a lot because this is not easy. This is a proof that the Mayan numerical system is a function because every figure is associated with a value. The point 1, the line 5, and the shell 20. So it's a function. And that's all.
Based on what we saw about the Mayan numbers, we need to put that knowledge into practice. The activity will consist in identifying and making operation with them. It will be divided into 3 levels. On the first one, you will need to only to identify the Mayan number. In the second one, you will need to add and subtract some numbers in a Mayan way, and the result you need to put it in the decimal numbering way. And the last level is as the same way of the second level, but with multiplication and dividing. They are not difficult exercises, but very good to practice. I wish you good luck.
Easy level. Three. 15. 12. Medium level. 16. 10. 6. Hard level. 10. 16. 2.
Hi, my name is Jose Maria Vera Sanchez. So, when talking about the objectives, basically the objective is to show the Mayan numerical system and how it worked when the Mayans used it in their time. like making precise astronomical predictions based on the calculations they elaborated because of the system. That also was the most advanced at their time, of course, and also they used it for astronomical and calendarical record keeping. Speaking of those ones, which were very precisely, especially because of that time. Also, there is the objective of showing how this system relates to the mathematical functions that we use nowadays, and also the explanation and the backstory of this last one. Okay, so when talking about our objective, so the objective is to show the Mayan numeral system, as we all know, and how it worked when the Mayans used it in their time, like making precise astronomical predictions based on the calculations. Okay, the calculations they elaborated because of this system that also was the most advanced at that time, and also they used it for other things such as astronomical and calendarical record keep, which were very precisely, especially because in those times they didn't have that much of ways to do this record keeping, and it was pretty precise.
Hello, my name is Constantino Munoz Neros and I can represent the history of the Mayan number. This Mayan number was invented by Mayan 2000 years ago. This have the notion of the zero that is so weird because the Mayans also have a very technical advances in that time, so it was so weird. And these have the combination of symbols that are difficult because it was a code that are composed by ray, a dot, and a character. This became more weird because the Mayans doesn't use the mathematical numbers to do mathematical equations. No, they use the mathematical numbers that they have to the days, the months, the years, and have it in the Mayan calendar. The system that they have in the mathematical numbers are be between from 0 to 20, and they get grouped. So we can say that the Mayans have a decimal system. So how was the order of the Mayan calendar? These have 364 days that are divided in 18 months, and they are divided in 20 days each month. At the final of the Mayan calendar, we have 5 days that are known as UF. Fact that we have the Mayan system is that historians know the Mayan system as the Mayan hieroglyphics because they have very similar with the hieroglyphics that are in Egypt.
The Mayan numeral system is an easy mathematical function because there is a relation from a set of inputs leading to sets of outputs, where every input is related to exactly one output. For example, the number 1 is equivalent to 1 dot. The number 2 is equivalent to 2 dots. The numerals consisted of 3 symbols which were 0, a shell-like shape, 1 a dot, and 5 a bar. This way the additions and subtractions were way much more easier and simple. Even if they did not possess a concept of what a fraction is, they resulted in very accurate astronomical observations with no instruments other than sticks. With the definition already said, we can know that the Mayan numeral system is a perfect example of this because every shape has a value which cannot be changed.
Hi, I am Ricardo and I am going to explain you what is a mathematical function. I am going to explain you what it is because the Mayan numeral system can be defined as a mathematical function. Well, a mathematical function is an expression, rule, or law that defines a relationship between two variables, the dependent variable and the independent variable. These kind of functions are used everywhere in mathematics, and also they are used in some physical relationship in science. The relationship between variables is usually represented as y is equal to fx. But this is not the only form to abbreviate the symbols. You can use also other symbols such as the g and the p. These symbols are often used to represent functions of the independent variable, that is dx. These symbols are also frequently used when the nature of the function is unknown or is unspecified.
Hello, I am Diego, and I will talk about the rules of the Mayan number system. The Mayan, as well as other Mesoamerican cultures, use a numeration system known as a vigesimal numeration system that is based on a total of 20 digits for each number. As well as the modern system, everyone nowadays uses it. It is positional, meaning that the position of the numeric symbol indicates its place value. It's considered that it was originally developed from counting using fingers and toes. The numerals consisted of only three symbols to represent them: 0 represented as a shot, 1 shown as a dot, and 5 illustrated as an horizontal bar. By the application of addition and subtraction, it is a relatively simple matter of adding up dots and bars, unlike our system where one's place starts from right and then moves to the left. The Mayan system places the ones of the bottom of a vertical orientation and moves up as the place value increases. After getting to the number 19, larger numbers must be written in a kind of vertical place, about the digit bigger than 19. Value format using powers of 1, 20, 400, 8000, 160,000, etc. Although in their calendar calculations, they gave the third position a value of 360 instead of 400.
Now for the activity, you will see on the screen a link to Nearpod. In this link, you will see a video which will have some questions. You will need to answer these questions in order to see how much you have learned of.
Hello everybody, welcome back. Today we're going to talk about the Braille alphabet. So let's get into it.
Braille is a system of transcribing print in order to keyboard and touch. The basic Braille alphabet is composed of 6 dots. The positions are normally numbered starting from the top of the left-hand column. This makes the Braille a set of combinations because each dot has an individual pattern.
I'm going to explain about the objectives that are divided into two sections, the general objective and the specific objective. The general objective is to give a complete explanation about functions and the Braille alphabet, including definition, system evolution, and how it works in order to make understand our audience the relationship between them. In the case of the specific objective, is to explain the functions relationship and the improvement and purpose of the issue for visually impaired. Finally, apply our knowledge and researches with help of a workshop, and there are both objectives.
A function is a rule which operates on one number to give another number. In other words, if we start with an input and we apply the function, we get an output. They have an independent and a dependent variable, as in the example.
Will talk to you about the relationship between functions and the Braille alphabet. In math, functions can be defined as an expression, rule, or law that connects and defines two variables, the dependent variable and the independent variable. In the Braille alphabet, in order to make the first 10 letters, we need to have the 4 top dots. In order to make another 10 letters, we need to have the dot number 3. And to make the last 6 letters, we need to have the dot number 6. This means that for each letter in the alphabet, there is only one specific combination and cannot be repeated. This helps the communication of the blind people, and this was the relationship between functions and the Braille alphabet.
An alphabet is a set of letters or symbols used to represent a basic set of speech sounds of a language. They are classified into two main categories. The first category is alphabet, where each character represents either a vowel or a consonant, and it needs at most 35 separate letters. The second category is syllabaries. This language requires 150 characters to represent each possible consonant-vowel syllable, plus 5 for the vowels. They represent the sounds of words rather than units of meaning.
Hi everyone, now I'm going to show you what is Braille. Braille is a system of reading and writing by touch used by the blind. It consists of arrangement dots which make up letters of the alphabet, numbers, and punctuation marks. This is a Braille cell that consists of 6 dots. There are several combinations and each one represents a Braille letter, number, or punctuation mark. Well, but how does the Braille alphabet actually works? Well, with this picture, we can understand how it works. In the first row, we can see the base patterns. In the second row, we can see that it's the same as the first one, but now dot 3 is added. In the third row, it's the same as the second one, but now they add the dot number 6. Now, the letters Ñ and W do not follow these patterns because they were added later. So, these letters are the rotation of the letters Q and R respectively.
I'm going to talk with you about the evolution of the Braille alphabet. So the Braille alphabet and its use have been spread worldwide. The history begins when the French university student Louis Braille, at his age of 15, in the year of 1824, developed a simple and an easiest way to represent French letters, using something called the Braille cell. That was a system using raised dots into columns. He based himself in the military encoding. The first one was the Morse code, also known as the Morse alphabet, that was a system of representing letters and numbers using signals emitted. Each Morse code symbol is formed by a sequence of dots and dashes. The second one was the night writing. This was an encoding system using symbols of 12 dots arranged to 2 columns of 6 dots embossed to a square of paperboard. The code for rendering mathematics changed several times during the first half of the 20th century, but in the 1952 the named code for mathematics notation was first created, and by the 72 the named code was standard. This system used a 2 rows and a 2 columns for tactile reading by the visually impaired.
Hello, welcome to the section of workshop. I'm going to explain you the general idea and the main purpose of this workshop. Okay, so the general idea of this workshop is to show how to use Braille alphabet with small balls or lemons and with egg cartons. And once you understand the alphabet, you will see that each letter corresponds to a different combination of dots, and you will be able to write different words on the cartons. Okay, and the purpose of this workshop is to participants of this activity empathize and somehow understand the situation of people with vision problems, and have a general comprehension to use Braille alphabet in a fun and interesting way.
The materials for this activity are 4 empty egg cartons, 10 lemons, scissors, and a maker.
Okay, so I'm going to explain the steps for the workshop. First, we need to take the egg carton and cut it so we can have 2 columns with 3 quadrants each. Then we need to numerate each quadrant starting from the upper left column and going down until 3, and then continue with the upper right column starting from 4 and going down until 6. Repeat the same procedure with the other 3 cartons. So at the end, we need to have 4 egg cartons, cut it into 6 quadrants, and numerated from 1 to 6 each. Based on the explanation that my classmates made and on the image above, the participants will be able to know how to write in Braille system. So depending on the letter that we want to do, we will place the lemons on the number of quadrants needed.
For example, if we want to write an F, we will place lemons on the quadrant number 1, 2, and 4. If we want to write an A, we will place 1 lemon on the quadrant number 1. Each egg carton represents just 1 letter, so we can only do words with 4 letters. This activity consists on asking to the participants to write some short words with the Braille system. These words will belong to a category that we will define. For example, nicknames, animals, colors, movies, etc. I have already 4 here. You just have to cut it 2 per 2. Gonna write the word cat. First, I got to do the C with the letters of the alphabet that is like the image. So here is the C. Each cardboard is a word. So here is the A, and I'm going to show you an image of each letter, and this is the T. So now I have formed the word cat, so you can see it. My name is Sarah. So first I have to do the S. That is like this. The S, the A that I already show you, the R, that is this, and the A again. Braille isn't just used for documents or books. It also has a host of the real-world purposes. Although it is made of a combination of just 6 dots, Braille can be used to represent a lot of numbers and so many letters. Braille is used in our everyday communication. Braille brings sight to the visually impaired or the blind people.
So this was the Braille system. I hope you enjoy it and see you next time.
Hello, and welcome to our project. Today we're going to introduce you, explain, and show you how an exponential model works, to be more specific in the case of a disease. So let's begin.
Throughout the video, we will know and learn some new formulas, theories, examples of the exponential model, and much more. All this will help us understand how it works and to analyze it from a different perspective. This work explains in a synoptic way the antecedents, importance, and classification of the exponential model. Additionally, the common use of this model for the transmission of infectious diseases is described in detail.
Before we start, we need to know what is an exponential model. Exponential models are solutions to the simplest types of dynamical systems like simple models of bacterial growth, which is related to the topic that we are going to cover, that is the spread of diseases. In the exponential growth of fx or y, the function doubles every time you add 1 to its input x. The process of doubling time in half-life is characteristic of exponential functions, indicating how fast they grow or decay. Because yes, there exist exponential functions that go down. But in this case, we're going to talk about only to the ones that grow. Exponential functions look similar to these linear functions. The difference is that we are working with exponents in which the x is the power, the variable is the power, not the base. They always have a positive number other than 1 as a base. And it's really important to know how to graph it. There are 2 options. Either the base is greater than 1 or the base is less than 1, but it always still positive.
The formula of the exponential model is f of x is equal to b times a to the x power, where a is the base, x is the variable, and b is the coefficient. If the base is greater than 1, then the graph grows taller as it moves to the right, and as it moves to the left, the graph becomes shorter. This is what we call an increasing function. And if the case is that the base is smaller than 1,
Then the graph slopes down as it goes to the right, and as it moves to the left, the graph becomes taller. This is what we call a decreasing function.
The exponential model plays a central role in applied mathematics. It is used in the finance to calculate the value of the term investments, in demographics to predict the size of a population, in health to analyze the spread of epidemics, and many other situations. An exponential model, therefore, makes it possible to refer to the phenomena that grow faster and faster, describing the importance of this in the use of health measures. Help us to devise effective programs for the control and eradication of infectious disease.
The use of quantitative methods based on mathematical models to study the dynamics of transmission and control of infectious diseases has notably gained importance among scientists and health professionals to devise effective control programs and interpret epidemiological patterns.
How the exponential model works and how it can be used. In this case, we want to explain you this by an example of the real life that in this case is going to be the COVID-19. And as you know, the sick people is increasing by the time. And with this, we can see a way to explain the exponential model that is our main objective. Also, we wanted to show you how to make your own exponential model by creating the formulas and showing to you and how we can use it. Also, we are going to give you some examples in order that you can understand this better.
So we can say that the interaction with the environment that surrounds the people is one of the highest causes of the rapid spread of the diseases. Also, the way people act throughout the entire day by touching their faces and surfaces. So, the thing we want to achieve is that with the data of the people affected by the virus, apply the exponential model, adding that the people understand it and can be able to describe how to use the model.
Well, the main function of the exponential model is to provide means that makes possible to the people to understand the disease in a population by different scenarios. In a sense, the central function of this is creating and analyzing the mathematical models. This to improve all the understanding and the analyze of the diseases in order to prevent the future situations.
And well, this workshop will help us to see in a funny, crafty, and interactive way the model and how the COVID-19 spreading fast period, the reason why so many people get infected. Also, this workshop will help us to demonstrate how it is easy for coronavirus and other viruses and bacteria to spread by physical contact in common areas and surfaces that may be contaminated, despite the constant hygiene that is maintained in those places.
So I'm going to explain about what we're going to need for our experiment or workshop, um, hoping that we help to make you aware of that you need to care more about the problematic we are living in. So we're going to need floor and a surface that you can uh, get dirty or stain without any problem.
So this is how we are gonna make the workshop. First, we are gonna ask some volunteers of the audience. Then, as you can see here, I paint the hands of the volunteers and I ask them to touch normal things as always. For example, here I ask the first volunteer to touch a roll, a bottle, and a calculator. And for my second volunteer, I ask her to touch a normal pair of glasses of laboratory, and also I ask her to touch a package of wet wipes.
Exponential model is a demographic and ecological tool, which can be useful in order to model the growth of populations and the epidemic spread of a trait among the population, based on an exponential growth.
am Eli and I will explain you our abstract. In this project, we will explain what are the four conic sections: ellipse, circle, parabola, and hyperbola, including how we can get them, the formulas of each one, all their features, how we can identify them, etc. The conic sections surround us in our daily life, but we don't realize it because we don't know them very well. But one of the purpose of this project is to help society to identify them in our real lives, and not only in the planes.
Well, in the example that we did, we make a conic section in wax paper. The idea was to make, to involve the wax paper in a more creative and innovative way. Some keywords that you're going to find in the video are right circular cone, menacums, foci, intersections, directrix, planes, center, radius, axis, fixed points, and distance.
Objectives. Our general objective is to make a complete description of the origin and formation of each of the conic figures, which include ellipse, circle, parabola, and hyperbola, and also make a description of their distinct applications of these figures. A specific objective is to describe the different types of conic figures, to understand the purpose of each figure, and acknowledge the elements and features of each of the conic figures.
Maths, conic sections are particular shapes formed by intersection of a plane with a cone, and depending on the angle between both terms, we can obtain four different conic sections: circles, ellipses, hyperbolas, and parabolas. As an alternative, by manipulating a piece of paper and making determined folds, the exercise of folding paper can be used for pedagogical purposes. To study and illustrate elementary planes, the key lies in geometrically interpreting what is being done when the paper is folded. There can be visualized, precise geometric concepts. Conic sections are used in many fields of study, particularly to describe shapes. Two massive objects in space that interact according to Newton's law of universal gravitation can move in orbits that are in the shape of conic sections. They could follow ellipses, parabolas, or hyperbolas, depending on their properties. With ellipse, one of them shows the constancy in the distance from any point to the focus on the other point, and all of them explore the relationship between all the crucial slides that the ellipse have and could have.
The applications of the conic sections. The conic sections are not used only in math, but can also be applied in many other fields of study, particularly to describe the shapes. Two massive objects in space interact according As stated by 19, with ellipse, one of them shows the constancy in the distance from any point to the focus on the other point, so it becomes a focus. And all of them explore the relationship between all the crucial slides that the clips have and could have. Page 7, Candela, 2019.
Hi, my name is Luis David, and I'm going to explain two conic sections that are the circle and the ellipse. A circle is a collection of points formed when its intersection with the cone arises from a common center point, and as long as the plane is parallel to the base of the cone. All circles have certain features: a center point, a radius, which is the distance from any point on the circle to the center point. Circles have an eccentricity of 0. Formulas. On a coordinate plane, the general form of the equation of the circle is x squared plus y squared plus ax plus by plus c. It's equal to 0. And the standard equation form is x minus h squared plus y minus k squared. It's equal to r squared, where h, k are the coordinates of the center of the circle and r is the radius. The case of an ellipse, it is formed when the sum of all set points distances from two fixed points, foci and directrices, is constant. Ellipses have these features: a major axis, which is longest width across the ellipse, a minor axis, which is the shortest width across the ellipse, a center, which is the intersection of two axes, two focal points for any point of the ellipse. The sum of the distances to both focal points is a constant, and the formulas of the ellipse are: the standard equation center at the origin is x minus h squared divided by a squared plus minus k squared divided by 2 squared minus 1, or x minus h squared divided by b squared plus y minus k squared divided by a squared. And the general equation for an ellipse is x squared plus y squared plus ax plus by plus f, and it's equal to 0. Thank you.
The general idea of the workshop and this project is to help people understand how conic sections work and how can they be formed in wax paper, making it by ourselves. Also, showing them the process step by step so they can find an easier way to learn and understand the topic.
The purpose of this workshop is to identify conic sections outside the planes, but also in real world, because in reality, conic sections that are circle, ellipse, hyperbola, and parabola surround us in our daily life, only that we don't realize it because it is already normal for our view. The materials for this experiment are wax paper, ruler, pen or pencil, and a geometric compass.
The procedure. Well, first of all, we have the materials. We need a wax paper, a ruler, a pen or pencil, geometric compass. The procedure. The first step we have to do is draw a circle in the center of the wax paper. The second step is with a ruler to make a 15 centimeters mark from the center of the circle. Next of that, the third step we have to do is draw a line from the mark of the vertex to a circle, and then fold the wax paper following the ones that are already marked. With these 3 steps, we have to repeat them 16 times and fold it 16 times, according to the lines we already made. And that will give us conic sections in the wax paper, as you can see in the video.
Hello everyone, we are Team 13 from 30 and we hope you're fine and safe at home. Welcome to our science fair video. Our project is about how logarithmic models are applied when measuring an earthquake. By the end of the video, we will show you how to create your own homemade seismographic. Are you ready? First of all, we need to understand what a logarithmic model is. As its name says, a logarithmic model is a model that is used to measure the magnitude of things. These things usually go from very small to very big. However, we have another model, the exponential model. It is the way that things either increase or decrease that will determine the model that is perfect for our situation.
The fundamental function of the logarithmic model is y is equal to a plus b in x, where all values for x must be greater than 0. The point 1, a is on the graph of the model, and b controls the rate of growth. So if b is greater than 0, the growth in the model increases rapidly first and steadily slows over time. But if b is lower than 0, then the key occurs rapidly first and then steadily slows over time. Logarithmic models can be used for several physical applications, like sound, earthquakes, and acidity. Now we will focus on how logarithmic works in measuring earthquakes, because naturally, these occurrences produce huge amounts of energy, so logarithmic scales are used to represent it.
What is an earthquake? Well, an earthquake is the result of forces within the Earth's interior that may affect the surface of the Earth. The energy is stored within the rocks, and when it is suddenly released by shearing movements along the Earth's crust, an earthquake comes out as a result. The area of the fault where the earthquake takes place is called the hypocenter. The point on the Earth's surface directly above the focus or hypocenter is called the epicenter. At first, these two may sound similar, but they have some differences. First, the epicenter occurs in the Earth's surface, while the hypocenter occurs beneath the surface. The waves that spread out from the hypocenter are body waves. From the epicenter, body waves and surface waves appear. And the last one is that the spread of seismic waves is measured 2D from the epicenter, while it is measured in 3 dimensions from the hypocenter.
Now that we know what an earthquake is, let's talk about how it can be measured. An earthquake's severity can be measured in intensity and in magnitude, which can appear the same thing, but they're not. Intensity is based on the observed effects of ground shaking on people, buildings, and natural features. It varies from place to place within the disturbed region depending on the location of the observer with respect to the earthquake epicenter. On the other hand, magnitude is related to the amount of seismic energy released at the hypocenter of the earthquake. It is based on the amplitude of the earthquake waves recorded on instruments which have a common calibration. These are what can be measured with the well-known Richter scale.
So the Richter scale was developed in 1935 by Charles F. Richter, and it is the most common scale used to measure the magnitude of an earthquake. Its formula is this one. Here, R represents magnitude, which is the value that needs to be found. A is the measure of the amplitude of the earthquake wave, and A0 is the amplitude of the smallest detectable wave or the standard wave. We all know that earthquakes can vary, so to make things easier, the Richter scale is developed in such a way that it is logarithmic. This means that whole number jumps indicate a tenfold increase. For example, an earthquake measuring 5.0 has 10 times the magnitude of an earthquake measuring 4.0. Also, the Richter scale is divided in 8 levels, which are the following ones.
Earthquakes with magnitude 2.0 or less are considered as micro, and these type of earthquakes are rarely felt. Now, from 2.1 to 3.9, this also happens daily. Only a few people can feel them, and some objects can shake, but this doesn't cause any damage. From 4.0 to 4.9, they can happen monthly, and they can cause failing objects because of the shaking, and most people can feel them. Now, going to a higher level, we have the earthquakes that go from 5.0 to 5.9. There can be damaged buildings that are not prepared for this kind of earthquakes, and everybody can feel them since these are strong. Now, from 6.0 to 6.9, they can damage every building, and shaking reaches a wider spread from the epicenter. And from 7.0 to 8.9, it can happen at least once per year, causing a lot of damage. And an example of this kind of earthquakes is the one that we experienced on September 19 of 2017, which left a lot of damage. At last, from 9.0 to 9.9, it can happen every 5 to 50 years. And as an interesting fact, there has never been an earthquake with a magnitude of 10 or above, but it could massively destroy everything.
Now, after understanding the Richter scale, we can use it now for diverse situations, for example, comparing two earthquakes. We come up with this operation, where M stands for each of the magnitudes and I for each of the intensities. We can use this formula to calculate any of the values shown. The way we can use this formula is by substituting values we already have into the formula. Let's imagine earthquake A is 15 times stronger than earthquake B, and earthquake B is
calculated to be approximately 2.3 degrees in Richter scale. So now how can we know the value of earthquake A in Richter scale? One of the latest logarithmic models have is that they're not linear, which means we cannot just simply multiply 2.3 by 15 because that not can be correct. Therefore, what we can do is just substitute the values they gave us into the formula. Magnitude A is going to be missing. And then we have to subtract magnitude B, which is 2.3. Then we should add equal to logarithm and in between brackets the difference of intensities, which is 50. After balancing equations and solving our equation, we get that the magnitude of earthquake A is 3.5 on Richter scale.
To conclude, it is important to mention that the original Richter scale is no longer used. It has been replaced by a more precise option called the moment magnitude scale, which was developed by Hiro Kanamori and Thomas E. Hanks. But it is based on the scale that we've been looking at for the past minutes. Nowadays, with the moment magnitude scale, we can measure earthquakes that have a value of magnitude less than zero, which is a very big advancement because with the old Richter scale, we could only measure earthquakes that were small if they had a value similar to zero.
Now it's time to carry out our workshop. As we mentioned at the beginning of the video, we will do a homemade seismograph. With this, we will be able to show how the scientists measure an earthquake by defining the magnitude and measuring its seismic wave amplitude, as well as its size. Also, we will show how the logarithmic model of Richter scale works with the help of our seismograph. In order to make our seismograph, we will need some materials that are easy to acquire. So go for some paper, something to write, and take note. Are you ready? Okay, the materials needed are a carton box, thread, paper tape, a marker, small things for the weight, some clay, wire, and something to cut.
And well, once we know the materials that we are using, we can start.
Well, first you have to do a little cut on the largest side of the box cover and in the base of the box, right here. Then without our wire, we do this kind of shape to insert the marker. Then you have to tie up to threads to these parts of the wire. After that, you make two little holes in the box, here and here. With the holes done, you have to pass the threads through those holes. And in the top of each hole, put a gripper so the threads won't get out from the holes. And make the same thing with the other hole. Then you have to add the plastiline to the wire so it has more weight, and also add weight to the box. And finally, you put the paper roll on a wire and place it in the box and pass it through the two cuts you did on the first part. And here it is how it will look with all the steps.
So now that it's done, we're going to test it. As we can predict earthquakes, we're going to simulate one. So as we can see, because of the seismograph being so sensitive to the movement, it can represent very well the magnitude of the earthquake. So the Richter scale is related to the seismograph because it was made to measure the representation of the earthquake made by the seismograph.
Good morning and welcome back to the Science Fair. We're Team 14 from third semester Group E, and we will be talking about conic sections and more exactly about the parabolic solar heater.
We are going to explain the functions and the application of the parabolic solar heater. Also, at the end of the explanation, we're going to have an activity, so don't miss it.
Hey, wait! But first of all, for us to understand what is a parabolic solar heater, we need to know what's a parabola. Basically, a parabola is a conic section that is formed by the intersection of right circular cone and a plane parallel to an element of the cone.
Okay, so the parabola has many properties, and one of the most important properties of the parabola is the reflective property. That says that any ray parallel to the axis of symmetry reflected off the surface of the parabola and goes to the focus.
Okay, so the parabola has some main elements, and some of them are the focus, which is a fixed point inside of the parabola. Then we have the directrix, which is a fixed straight line, which is perpendicular to the axis. Then we have the axis, which is a line passing through the focus and the vertex. Then we have the vertex, which is where the parabola takes its shape. Then we have the lactus rectum, which is a line that goes through the focus, and it's also a straight parallel line.
Let's talk about the history of parabolic solar heater. The first record about the use of energy for cooking are from 1767. Then, around the 1860s, Augustin Mochet combined the box heat trap with mirrors in order to create a solar oven. Now, let's jump in time, and in the 60s, the United Nations started working in more complex solar heater systems. And nowadays, solar heaters and parabolic solar heaters are more common, and we should start using it if we want to help our environment.
A parabolic solar heater is a solar thermal energy collector. It's designed to maintain all the sun radiation into a large surface area and the focus. Or, in other words, it contains all that radiation into a small focal point area, increasing the solar energy by more than a factor of 2, which means more overall heat per square meters of true.
The shape of the concentrating solar collector must be specifically designed so that all the incoming sunlight reflects off the surface of the collector and arrives at the same focal point no matter what part hit first. This shape is the parabola.
And now you might be wondering how the parabolic solar heater works. Well, I have the answer. I'm going to explain how they work. These solar heaters use a system where the sun's energy is captured by using large mirrors that are connected to track the sun's movement throughout the day. When the sun's heat is reflected off the mirror, the curved shapes send the most of that reflected heat onto a receiver pipe that is filled with a specialized heat transfer fluid. The thermal energy from that heated fluid generates steam and electricity. Once the heat is transferred, it is reused again.
The radiant energy will be the energy responsible of heating the focus of our parabola. This type of energy, also called electromagnetic energy, is transmitted through an elementary particle called a photon. It interacts with matter to transfer a fixed amount of energy. This energy has a speed of 3,000 kilometers per hour, and it travels in space forming waves of various lengths and frequencies. This type of energy is present in the solar heat that will be the heat responsible of heating our parabola. Something important to take into account is that the radiant energy is able to heat an object only if atoms, molecules, of this object can absorb electromagnetic waves of a specific wavelength, and that the radiant energy is different to the thermal energy. Thermal energy generates heat by the movement of particles, while the radiant energy, as said before, generates the heat if a surface absorbs the electromagnetic waves.
For this experiment, we are going to need 6 materials. The materials required are silicone or glue, cardboard, a cutter or scissors, a box of shoes, aluminum foil, and black paint brushes.
Solar heater that is awesome because we apply all the concepts that we have seen across the video. So we're gonna teach you. It is easy, simple, done the best engineer in the world, but we are gonna prove how this can and may cook the food. So you can make like a barbecue. No, not like that, but it is very cool how if we apply the concepts that we show you, it is simple but very efficient solar heater.
The procedure is very easy. The first thing you have to do is to paint all the box of black and take the measure of its width and its height. Our box measured 14 centimeters of height and it has a width of 22 centimeters. While the painting is drying, calculate the focus. For this, we're going to use
Focus is equal to the half of the width squared divided by 4 times the height. In this case, it would be 11 squared divided by 4 times 14. That is 121 divided by 56, which gives us 2.16 centimeters. And there is it. You have the focus.
Then, in a cardboard, put the aluminum foil and make a parabola with it in the box. Paste it with glue and do a hole in the height of the focus in both faces of the box.
Thank you so much for your attention, and don't forget to do your activity, and we will see you here next time.